One of the ways that I actually like multiplying polynomials when it's not as easy as a 2 by 2, like two binomials, or a binomial trinomial, because then it's FOIL and distributing. This one would be a little bit more hectic to distribute. So I make like a multiplication table. So I'm going to take the one on the top, make sure I'm actually writing, and I'm going to put the 5x cubed plus 2x squared minus 3x plus 11 along the top. And over here, I'm going to say 3x cubed minus 5x squared minus 2x plus 1. So I just wrote the problem in a table. Now, just like a multiplication table when you were like in first grade learning how to multiply, the same thing applies. 5x cubed times 3x cubed is 15x to the 6th power. And I just multiply all the way down or all the way over, whichever way I want to do it. 6x to the 5th, negative 9x to the 4th, and 33x cubed. And then I just keep going. Negative 25x to the 5th, negative 10x to the 4th, positive 15x to the 3rd, negative 55x squared. Negative 10x to the 4th, negative 4x to the 3rd, positive 6x squared, and negative 22x. This one is just a times 1, so really I'm just copying that. That doesn't always happen. Okay, so take a second, double check me, make sure I did everything right. Okay, so now that we have it in a multiplication table, what we're going to do is we're going to add, and if you notice on the diagonals, and I'll write one down in the middle, I don't know, it's red. So if I look about this big diagonal, do you see how all of the x cubes are there? That's going to be your like terms. And I'm only going to do every other one, just because I don't want to confuse you with too many highlighters. So if I look at that and I start way up here in the corner, right here, I have 15x to the 6th by itself. Then I add these two together and I get negative 19x to the 5th. Then I go to the x fourth to the column and I get negative 29x to the 4th. I get plus 49 x cubed minus 47 x squared minus 25x plus 11. So that is my answer. That's what I get when I multiply those two things together. So what we're getting ready to do now is we're going to actually work backwards within a table instead of actually working forward. So it should hopefully save you a little bit of time. Okay, so now we're going to move down to the bottom. And we're going to, ooh, I of course did that because why wouldn't I? Okay, and now this is going to be more like a puzzle. And it's actually, you don't have to fill in the whole puzzle to do this. Instead of doing, the only possible way to do this would have been long division. Okay, and no one wants to do long division. So there is a way, and I kind of like, Mr. Noiser taught me this really quickly, like 2 days ago, and I thought it was really neat. So I was like, let's make a day out of it because it can be A, fun, give you another day before you have to take your test, and if you have anything else you need to make up. It doesn't really take us a lot of time to do this. I am going to put the bottom, my divisor, over here. X squared minus 2x plus 1. Okay, write it small so you can see it somewhere, but that's where it's going to end up. Now, I am looking for my answer. my top. I'm going to highlight this and I'm going to unhighlight it in a second. This is what I'm looking for. I don't know that. But what I do have is I have what I get when I add my diagonals. Okay? I have that, so that's what I'm going to put in. So when I look, and I'll keep my highlights on every other one like I did before. And actually, I might even color code. Who knows? Last time I color coded, and I know certain people will like this in red and green for Christmas. Okay, so let's look. It says the first thing I get is a 4x to the 6th power. So that's going to be my 4x to the 6th power. Did I miss one? Dang it. Of course I missed one. Especially when I color code. Okay, but I get 4x squared. Then I get minus, thank you, minus 6x to the 5th minus x to the 4th plus 3x to the 3rd plus 4x to the squared, x squared, minus 7x plus 3. Okay. I want you guys to take a second and figure out where I got those. I did try to color code so you could see that just like before, instead of, putting in the top and multiplying, I'm actually getting what I do when I add. So when I add everything in this box, this is what I get. Everything in this box, this is what I get, and so forth. So it ends up being a puzzle, and I'm going to work at it. I'm going to change the color of my pen. Now, this is why I say this is much easier than synthetic division or long division. When you have a long, complicated one, couple of things. I know that no matter what, in this box is a 3, because there's only one box that adds to 3. On the same way, there's only one thing that can go here, because there's only one box that adds to 4x to the 6th power. So I can figure out something over here. Do you see this x squared? Something times x squared gives me 4x to the 6th. What? 4x to the 4th power. Now, I know also this one is a 3. Something times 1 gives me a 3. What? 3. Now, my goal is to find the middle 3 columns. So I can work at it any way I want. I'm going to actually start, because I'm going to need this red and green to get over here, right? This one, since I know that this is a 3, 3 times negative 2x is negative 6x. This is 3x squared. Now, what does that do for me? I now have this red diagonal. So I need it to be a negative 7x. It's a negative 6x. What has to go there? Negative 1x. Because together they make negative 7. And now that I know that, I can find the number on the top. Negative 1x, something times 1 gives me that. Negative 1x times 1 gives me negative 1x. Happens to be a 1. It's actually kind of nice. So now I can fill in this green box if I want. This times this gives me a positive 2x squared. The x squareds are adding up to, I don't know why my positive didn't show up, positive 4x squared. So I have how much? I have 5. I want it to be a 4, so what do I need to do? Minus 1x squared, which means this has to be minus 1x squared. So all that I'm missing right now is this one. I'm going to use my red column just because I want to not use this 1 down here because it's going to make it a little bit weird. So negative 4x to the fourth times negative 2x is negative 8x to the fifth power. Do you guys see that and agree with me? 4x to the fourth times negative 2x is negative 8x to the fifth. How much do I want this red to add up to? So I'm going to have to add 2. Now, if I multiplied by x squared, what did I actually have to multiply by to get that? 2x to the fifth divided by x squared, really. 2x cubed. And I have a couple of checks in here, checks and balances. My powers go 4, 3, 2, 1, 0. That's always a big thing. This is a plus sign. And guess what my answer is? This is my answer. That is finished. Why do I have to finish the chart? Do I have the answer? This is why this might be a little easier than doing long division. In long division, you have to sit there and do it all. Here, I just have to do enough of this table to be able to get my answer. Okay, couple of fun facts when you do this. I want to go over a couple of fun facts. Are we ready? Okay. I'm going to scoot this up, hopefully. Yes. Okay. 1 and 2 are just multiply. Okay, that's pretty easy. Not too bad. Here, number 3 is pretty straightforward. 4, 3, 2, 1, 0, 2, 1, 0. All my powers are there. But look at number 4. Do you see how my power disappears? In my table, I have to account for that. The bottom number will always tell you how many rows you have. So here I'm going to definitely have, no matter what, 3 rows, right? 1, 2, 3. Because I have to put in x squared minus x plus 3. Over here, I am also going to have 3 rows. I'm going to have 3x squared, 0x minus 2. Even though it's going to produce a row of zeros, I need to have a placeholder. So in this whole row, it's just going to be a bunch of zeros when you do it. Down here, same thing, only there's going to be zeros along the diagonals. Things are going to add to 0. That still happens. I'm going to have a 3, and then about my diagonals, I have to take care of the fact that it's x to the fourth minus or plus 0x to the third plus 0x squared. Kind of a thing when I'm going around the outside. And it's kind of a puzzle, on how many rows and columns you need. When I did it, we can go back to this. Actually, I can just show you the rows. When I go back over here, because I already made my table. Of course, I moved it. Okay, so when I did it, the power was to the 6th. It was 4x to the 6th power, I believe. I'm going to get over here and move it. Divided by x squared. What is 6 divided by 2? 3. Right? 3? And then I always said, what is this? And then I always add 1, and somehow magically it kind of works, but that gives me 4. So it doesn't even work for that. No, but you know what I mean? I can't come up with the pattern. There has to be a way to figure that out. But like I said, Mr. Noiser just showed me this, and I researched it, and I couldn't even come up with that's the closest pattern I could get, was that if I divide these two, I get to the 3rd power, right? And I did this already, so what was my actual answer? It was to the 4th power. Oh, because when I divide exponents, I subtract. That's why. I'm an idiot. So 6 minus 2 is 4 plus 1 is 5. So the reason I did that was because if it's to the 4th power, I have to account for the one without an x. So I always add 1. That seems to work, but that doesn't mean, that's a good thing. I don't know if it works every single time. But just subtract the 2 powers and then see if that could work.